Hi, in this video we're going to consider a very practical problem, 3.1.4, where we're choosing between two financing plans for buying a car. In both situations we'll be finding the monthly payments and outstanding balances at a certain moment in time. Smith is borrowing some money, $20,000, to purchase a car. The car dealer finances, essentially gives Smith the money, and offers Smith two alternative financing plans, payback plans, to make this an amortized loan that is paid back out over time. Both require monthly payments at the end of each month for 4 years, so that'll be an annuity immediate with 48 monthly payments, starting 1 month after the car is purchased. All right, two options. The first option has a 0% interest rate for the first year, followed by a 6% nominal annual interest rate for the following 3 years. It would be compounded monthly, even though it doesn't say so. In option 2, you've got a 3% interest rate for the first year, compounded monthly, followed by a 5% nominal interest rate, compounded monthly, for the following 3 years. For each of 1 and 2, find the monthly payment and also find the outstanding loan balance at the end of the first year. All right, let's think about option 1 first. All right, well, actually, maybe I should consider both options at the same time here. Okay, let's just draw one timeline, 0, 1, 2, 3, etc. 48 months, it might be good to mark a 12 and a 13 on here as well, because that's when the interest rate changes. 4 years is 48 months. The payments for option 1, let's call those K1. These are level payments for the entire 48 months in both situations. And for option 2, we'll call the level payments K2. All right, as far as you, the consumer, goes, if you think for over the 4 years, the better option is the one that has the lower monthly payment. If you're thinking in terms of perhaps selling the vehicle after 1 year, looks like option 1 would be better. Probably you're going to have a lower balance after 1 year with option 1. But we need to first find these payments. So let's think about option 1. And in both situations, the idea is the value of the loan, $20,000, which is at time 0, is equal to the present value of all these payments in both situations. In situation 1, for the first 12 months, there's no interest. So the present value of those first 12 payments at time 0 is equal to 12 times those payments, 12K1. And then for the remaining 36 payments, there's a 6% nominal annual interest rate going on, which would be half a percent per month. We would want to discount this back to time 12 and then go back to time 0, but again, there's no interest during that first year, so we won't have to multiply by any power of v for this first option. But we are going to have K1 times A36. Again, 6% divided by 12 is 0.005. We can factor K1 out of this if we like. So once we find A36, add 12 to it, we can divide both sides by that thing to get the value of K1. Let's use the calculator now. I'm going to figure out A36. I'm not going to write down the formula for it. I'm just going to use it in my head here. Hopefully you've got enough practice with this where you can do it in your head as well. 1 plus I in this situation would be 1.005, where I would be the monthly interest rate. Take its reciprocal to get V, the monthly discount factor. We need to raise that to the 36th power. Subtract that from 1. And divide by 0.005. So it looks like this value is about 32.87. I need to add 12 to that to get 44.87, then divide both sides by that. Take its reciprocal and multiply times 20,000 to get the monthly payment out, but I multiplied by 200,000. Let me divide by 10 now. So the monthly payment is K1 is 445.72 to the nearest cent, and that's how you'd want to report your answer. Let me carry more decimals in case I need more decimals later on. Okay, but again, your answer you'd round to the nearest cent if you were dealing with dollars here. What about the second option now? Same principle. The loan amount, 20,000, equals the present value of all the payments. We got the first 12 and the last 36 again under different interest regimes. But now we don't have 0% during the first year, we have 3%. So the present value of these 12 payments is going to be K2, looking up here, A12, 3% divided by 12 is 0.0025, 1/4 of 1%. And then for the last 36, we're going to have a K2 A36 with a given interest rate, also times V to the 12th power, where the V would go with the first year's interest rate of 3%, 0.0025 to the 12th power. What's the interest rate per month for the last 3 years? Take 5% and divide by 12. 0.00416 repeating. I'll write that right there. That's one quantity. It's getting multiplied by V to the 12th and also K2. Let's go ahead and factor out a K2. Like this. And now I think I'm going to use my storage features here. Let's find this A first. So I need 1 plus I to be 1.0025. V will be the reciprocal of that. I need to raise that to the 12th power, subtract from 1, divide by 0.0025. This quantity is about 11.807. Let me store that in register 1. Let's find this V. It's 1.0025 reciprocal to the 12th power, something I already did calculate. Let's go ahead and store that in register 2. And now this thing, 1.00416 repeating. I think I'm out of digits. I can't put a 7 at the end there. That's okay. Take the reciprocal of that, raise it to the 36th power, subtract from 1, divide by 0.00416666. That's about 33.3657. Let me go ahead and store that in register 3. I think I do need it later on. Okay. Multiply what's in register 3 by what's in register 2 times recall 2. Now add what's in register 1 plus recall 1. This quantity in parentheses is about 44.188. Take its reciprocal times 20,000. K2 is a bit bigger, 452.61. And if you carry more decimals, you get that. So as far as over the entire loan, K1, the option 1 has the lower monthly payment, so you'll be paying less interest over the entire life of the loan, the 4 years here. So option 1 is the better one. Option 1 would also be the better one as far as the outstanding balance at the end of the first year, because there's 0% for the first year. So it looks like in both situations, option 1 is better. Let's now find those outstanding balances now for both options here. Balance at the end of the first year after 12 months. Option 1, we'll do in red here. Outstanding balance at time 12. Since there's 0% interest for the first year, it's probably best to do this with the retrospective method. You'd have the loan amount promoted in time to time 12 But again, there's no interest that first year, so it's just the loan amount minus the future value of the first 12 payments at time 12. But again, there's no interest, so the future value is 12 times K1. Okay, so that is going to be the outstanding balance after the first year for the first loan. Just for the sake of being careful, let's go ahead and type all these digits. 445.7220201 times 12. Subtract that from 20,000. For loan option 1, the balance at the end of the first year is 14,651.34. I will round that one. Option 2 is going to be worse. You're going to have a higher outstanding balance at time 12, and it's a bit more complicated to calculate. We could do, again, retrospective or prospective. It doesn't matter. Let's do prospective this time. Look forward in time. Let's take the present value of these 36 payments there at time 12, 1 month before the first of those. So you'll get K2 A36.00416 repeating, and that was the value that was in register 3. So that's good. I can now recall that. From register 3, recall 3. That's the A. And K2 we found to be this 452.61. Need to multiply 452.61. Let's go ahead and do more decimals. 0.93 should be good enough. We have a balance of 15,101.68. Okay, so option 1 again is better in both respects, a lower monthly payment, and at least at after 1 year, a lower balance. So if you tried reselling the car after 1 year, you could pay off that loan more easily.